The left and right behavior of a graph is based on whether it's an odd power or even power as the highest degree, right? So if it's an odd power, it's going to be similar to, what's the simplest odd-powered function? The simplest odd-powered function that you have is y equals x, right? That's very basic, right? This is the graph for y equals x. So think about that. If you have an odd power, so if the highest power is odd and it's a positive coefficient, it's just going to, the left and right behavior is going to mimic this graph. So your answer, the left behavior goes down, the right behavior goes up. If it had been an even graph, again, an even graph, the easiest one that you can have would be this, y equals x squared. And so you would know if it was an even graph, the left and right behavior is up. Now, if, again, the negative in front of each of these is going to reflect your graph vertically. So a negative in front of an even graph will be down and down. A negative in front of an odd graph will be up to the left, down to the right. Okay, so all you need to know is these two, which you guys should be extremely familiar with, and you get it. Okay, now, in addition to that, finding the y-intercept is very easy, because the y-intercept is the value of y when x is what? 0. So if you just plug in a 0 for x, 0, 0, 0 plus 4, you get your answer. And really the shortcut is if you're dealing with a function written in standard form, and so if it's written with no multiplication or factors left to expand out, the y-intercept is just your constant. So 4, this is your y-intercept. Okay? And so you can put that right in and answer those 3 questions without even having to refer to your calculator. All right, so the bottom ones, though, you do need to use your calculator. So let's take a look at how you would solve for these. Okay? Now, regardless, you're probably going to go into your, or enter this as a function in your y-editor. So that's usually what you'll start with for these types of problems. So if we take this equation, x to the 5th plus 2x squared minus x plus 4, and we enter that in our equation, double check to make sure it's entered right. So x to the 5th, 2x squared minus x plus 4. And we can go in and we can view our graph. So the green diamond F3 allows us to view this graph. And now I'm going to change the window settings so we can talk about this later. Okay, but this green diamond F2 allows you to change your window settings. Your default settings are -10 for the minimums, +10 for the maximums, and 1 for the scales. And so this is what your graph would look like if you're in just the default setting for your window. -10 for your minimums and +10 for your maximums. All right, so if we're looking at this, we can see the left behavior, right? The left behavior goes down and to the left. Our right behavior goes up and to the right. So we can confirm our behavior by looking at the graph. The y-intercept, again, we can see that it looks like it's 0, 4. You can confirm that directly by hitting this F5 Math tab and choosing Value. Value lets you find the value at any given point. So if we know that x is 0, all we need to do is type in a 0 and hit Enter, and it gives us the corresponding value 4. So again, even though you can do these without your calculator, doing them on your calculator is very, very simple and quick. All right, the X-intercepts, another story. There's 2 different ways that you can approach these. You can, if you want, stay right in your graphing utility and solve for the X-intercept. The X-intercept are the solutions or zeros, real solutions, rational zeros, rational solutions. There's a whole bunch of different things that mean the same. All those mean X-intercepts. Okay? And so if you look on your calculator, you can find your zeros using this F5 Math tab. It's just the next command down. Your 0 is going to be where the graph crosses your x-axis. So you do need to pick a lower and upper bound in case your graph has more than one x-intercept. So as long as we move our cursor to the left of this intersection, and it is, we can hit Enter. That's our lower bound. Our upper bound, is anything to the right. Let me reset that. All right, so for our 0, the lower bound is to the left of that intersection. Anything to the right of the intersection is our upper bound, and then you're going to find what that point is. In this case, it is negative 1.61. And then if you look at this other number, again, we're probably rounding to the nearest hundredth, 10th or 100th on these. You have 2 times 10 to the, remember what this E stands for, it's scientific notation, 2 times 10 to the negative 13. What that means is you have, as you move this decimal over, you have 0.12 zeros and then the 2. So what is that pretty much equivalent to? 0. Okay, so double check for E's. If you see an E in your answer, understand what it means and apply it. And then you should also, it should be a double check because your X-intercepts are always going to have a Y value of 0. That's what the X-intercept is. It's the value of X when Y is equal to 0. And now there's an alternate way that you could have found your X-intercepts. My suggestion is if you only have one X-intercept, just use your graph and then the 0 command with a lower and upper bound to find it. But if you have more, if it crosses more than one place, you might want to go to your home screen. The other way that you could find zeros is just take your function and set it equal to 0 and solve for x. So because we've entered this in our function or in our Y editor, what we can do is we can take the solve feature, use function notation and take y1 of x, which is going to pull out that function that we already entered into our Y editor, and set that equal to 0. Solve for x, so comma x. And this is going to give you all solutions or all X-intercepts. So what I should see on here when I hit enter is just one. There's only one X-intercept or one solution, or 1, 0, or however you want to describe that. And it should be negative 1.61. And so what we see here as it calculates it gives you that answer. So negative 1.61 is your X-intercept or 0. I don't care which way you use, or which way you apply those. Like I said, though, if you only have one X-intercept, it's probably easiest just to do it on the graph here instead of going back to the home screen. All right, so that's the stuff that is a review from yesterday. Are there any questions on finding those pieces of information?
Can you show me the left and right?
So again, you just look at the graph.
No, without looking at the graph.
If it's an odd power, if the leading power, the degree of the polynomial is an odd number, it goes up and to the right and down and to the left. If there's a positive coefficient, if there's a negative coefficient, it gets reflected this way, and it would go down and to the right, up and to the left.
Okay.
If it's an even, if the highest power is even, it's going to look like this U shape. It's going to go up and up to the left and right. If it's positive, it's get reflected across here. If it's a negative, it would be down and down.
If it's a negative even, like
if it's a negative with an even power,
okay.
Yeah. All right. Any other questions on those? Okay, so let's talk about this what's called relative extrema is the points, but a relative maximum and a relative minimum. All that means is you can see on here there's little hills and valleys in our graph. Okay, the hills are relative maximums, the valleys are relative minimums. Okay, there's this point right here where it switches from going up to down or from increasing to decreasing is a relative maximum point. It's not the maximum of the whole graph because it continues infinitely to the right, but it is a maximum within a defined domain of that graph. So that makes it a relative max. If we want to find the relative max and mins, we do the same kind of thing that we did with the parabolas and their maximum and minimum, and the vertex of a parabola, except we're just limiting it to the relative with respect to a specific domain. So the F5 Math tab, and let's find our relative maximum first. So we choose maximum. We need a lower bound. The lower bound of a maximum is going to be to the left of it and below. So my cursor is already set to that. And then choose a upper bound for this relative maximum. So again, we have to be to the right of that maximum, but the cursor still has to be below it. So this is to the right and below. If I kept going, this would be to the right and above, so that doesn't fit the condition. So I need to be to the right of it and below it. So my cursor is set there. I hit enter, and it's going to give me the coordinates of that point. So negative 1, 6 will be my relative maximum point. I only have one relative maximum. My other extreme point is this relative minimum. So I can find that using the same concept. F5 Math tab, choose the minimum, so number 3. Choose a lower bound. Now for a minimum, the lower bound has to be to the left but above. So my cursor is to the left of this lowest point, but it's above it. Choose my upper bound. It can be anything to the right and above that lowest point. So again, I'm anticipating my lowest point's right about here. So my cursor is to the right of that and above it. Hit enter and I'll get my relative minimum point, 0.25 and 3.88. Okay, so those would be my relative minimum coordinates. All right, the last thing that you might be asked to do is evaluate the function. Okay, and so if you're asked to evaluate the function, again, there's no reason that you need to leave your graph screen. All you need to do here is go to the F5 Math tab, choose value, and then just type in what they're asking you to plug in for x. Type in a -2, and it'll evaluate the function, the y value, when x is -2. So we get an answer of -18 for this. Now, once again, you can go to the home screen, and you can evaluate the function just by entering function notation. So we could take our y1 function, plug in a -2. So using function notation, write y1 of -2, and hit enter, and it would confirm that -18 is our answer for that.